Thanks for joining us. My name is Jie Liu from Pinterest. Today I will going to present our work, Decoupled Entity Representation Learning for Pinterest ad ranking. As you can see, we have all the authors, contributors from many teams at Pinterest ad ranking. Let's start with the main motivation of this work. So we're mainly interested in how to achieve cross-domain knowledge transfer at Pinterest. As we know, Pinterest is the visual inspiration platform that allows the user to view, save, or search pins. So they are mainly come here for shopping the best ideas around the world across their different life moments. To support such multiple surface user experience, we have a lot of teams across the core and ads working with ML. So how to leverage each of their individual domains information to benefit all the downstream use cases is always a challenge. By domain here, I mean basically each team has their own training data, their own models, their own business goals. So the solution we propose here is that we can build a large upstream model and let it train on different individual domains. And we can learn multiple user pin embeddings and use that as a feature to help the downstream models. So what's the benefit of this approach? Apparently, this approach can improve the downstream model performance. This is because all these embeddings are trained in a cross-domain way. They carry the information from another domain. And one benefit here is that we can, one benefit here is the upstream model does not need to be served. So we don't need to care too much about the infra cost or serving cost. We can keep scaling up the model by adding more features, longer sequences, and add more capacity in the upstream model. This way, we believe we can help the early funnel ranking by using the embeddings from a very large model, such as as retrieval or as lightweight ranking. And also, you can improve the code start issue. If we can be able to train some embeddings from a data-rich domain and apply to the data-scarce domain. And we can reduce the infra cost by moving some feature used by the downstream model to the upstream. So you can achieve the neutral performance by reducing the infra cost. So here's an example of these data domains. We can use as engagement data, attributed as conversion data, and some conversion in another attributed window or come with some ingestion delay. And we have a synthesized data set. And for organic, we can leverage a huge amount of engagement data from the organic side as well. Let's take a little deep dive into how we design the model. We adopt a multi-tower approach. So the tower output will be the entity embedding. And one thing I want to point out that each tower should only accept the features of its own type. So this is try to keep the stability of the embedding instead of just blend everything from other types. And then we can combine with other features and feed everything into the overall interaction tower. And also we can add the supervised learning loss, which is regular labels like CTR, CVR labels. And on top of that, we can also use self-supervised learning loss on the pair of user and pin embeddings. So this is to achieve a better semantic cluster, and also we found it to boost the performance as well. As I mentioned, we can scaling up the model. Here we adopt a DHEN architecture in the tower, so we can keep adding layers. After that, we will pass the incremental training paradigm. That means each day we'll train a new version of each day we'll train the upstream model in an incremental way so that we can gradually update the embeddings. And then we will pass through a feature aggregation step, which means we don't throw away the old embeddings. We will try to aggregate the feature, and then we can do the feature backfill and also serving the feature online. One interesting finding here is that for the aggregation heuristics, we find that adopting a moving average type of aggregation will help boost the performance the most. That means every time we keep the historical version and we do the weighted average. And we can see from the table, if you add a very high weight on the historical part, that will boost the performance the most. We have a hypothesis that maybe our embedding the most help the system mainly through the preservation of the historical information. Here are some offline results. We basically test the embedding trend from the CTR and CVR model, and then they will apply to the same two downstream models. As you can see here, the more embedding you add to the downstream models, the more lift in the offline you will have. So here are the online results. Right now, our embeddings have a lot of successful launches across the ads and the core admin interest. So these are the four most eminent examples. And by the time I arrived at Europe, we also have another successful launch just approved. So yeah, thanks very much for your attention, and I will happy to take any questions.
Hi, thanks for the talk. I have a question on, are you using the user and pin embeddings directly, or using the final layer embeddings? Because then I'm assuming then you'll have a combination of user pin embeddings. That seems like a high cardinality. So I'm just wondering what you're actually using in the downstream task here.
Yeah, thanks. Yeah, I think this is just up to the user up in the downstream. You can use that in many ways. So you can use that separately or blend them all together. And you can also cross with other embeddings as well. And you can even do the crossing between the user and pin embeddings. We also see the gains as well. Yeah.
I have a question about the phrase there about avoiding blending other type of features into an entity tower. So does this mean that when producing your user embedding, you don't take any pin features? And the reason I ask is because, again, traditionally, you would be doing that, right? You would take all of the pins the users interacted with to produce an embedding. So yeah, do you see that this kind of leads to better outcomes for the final objective?
Yeah, that's a very good question. We have, based on our real-world experience, it's important to keep the stability. Otherwise, if you use the feature, when the feature was exactly produced by a data role that contains other pins information, it won't be useful when the user interacts with another candidate pin. And another extreme example is that if you want to include some search queries, like a query-side feature, that will cause the instability so strong that it will even hurt the downstream performance. From our experience, it's definitely recommended to keep the purity of the embedding. Yeah.
Hi, thanks for the talk. I have a question. Do you add some kind of dependency between the training of the downstream tasks and the update of the embeddings daily? Because the embeddings will change for a user, and the downstream task may be trained on the old embeddings. And do you see some kind of drop in performance when the embeddings changed or not?
So I don't think there will be any drop because so your question, I guess, is the downstream model will see everything, but our embedding is only trained inference daily. But as I mentioned, we also have the aggregation heuristic. We actually always keep the historical information and do a proper weighted average, so that can help boost the downstream model. In the real world, it's like a downstream model usually see a shorter training window, like after 1 year, because of the data retention. They only see a limited time window, and our embeddings can help them because they keep a very long information long time ago.